It was supposed to be an ordinary tech demonstration. A small group of engineers gathered in a remote industrial yard on the outskirts of Johannesburg. Cameras were rolling, drones were in the air, and an unfamiliar electric vehicle sat quietly under the sun. Sleek angles, armored panels, and a matte gray exterior that gave it a striking resemblance to Tesla's Cybertruck. But this was no prototype from Silicon Valley. It was built in Africa. And it was about to showcase something Elon Musk himself has never managed to bring to market: completely wireless energy transmission. To understand why this moment went viral, we need to rewind a few days earlier. A clip surfaced online, grainy, shaky, the type you'd scroll past on social media until the caption stopped everyone. Wireless Cybertruck? South African team pulls it off. The video showed an engineer unplugging a charging cable from the vehicle, stepping back, and the vehicle continued running. No wires. No charging pads. No visible power source. Within hours, tech forums lit up with debates. Some called it fake. Others said Tesla should acquire the team immediately. But the loudest reaction came from an unexpected source: Elon Musk himself. He posted a simple comment under the viral clip: "Interesting tech. Would like to see more data." For most people, those 6 words would be enough. But for the South African lab behind the innovation, it was a direct challenge. So they invited Musk to watch a full demonstration. Fast forward to the Johannesburg yard. Engineers stood around nervously adjusting instruments. Local journalists whispered predictions. And technicians wheeled out what looked like a compact control module, housing antenna-like coils. The lead engineer checked his watch. "Any minute now," he said. The demonstration began. One of the technicians raised a handheld display, showing the Cybertruck-like EV's battery levels. Another nodded to a power specialist, who activated the wireless transmitter. A soft hum filled the air, hardly noticeable, but enough to make the crowd lean in. The vehicle rolled forward, silently, effortlessly. Then came the twist. They lifted the transmitter unit off the ground and onto a metal platform several meters away, without disconnecting anything. The truck continued moving as if nothing changed. That was the moment the international tech community snapped awake. Because what they were watching wasn't inductive road charging like in Sweden. It wasn't wireless pads like the prototypes in Korea. It was mid-range wireless power transmission, the kind that engineers around the world claimed was decades away. The official observer from a major U.S. energy firm watched with his jaw clenched, scribbling notes furiously. Local university students erupted in whispers. Drone footage captured the vehicle circling the yard without losing power for more than 7 minutes. But the real highlight of the demo was yet to come. After a quick protocol check, the engineers shut down the vehicle completely. Then they restarted it, not by pushing a button on the dash, but by sending a power pulse wirelessly from over 20 meters away. The observers stared at the display. System online. Voltage stable. Load balanced. One of the American observers muttered under his breath, "If this scales, charging stations are done." When the live stream ended, the tech world exploded. Scientists demanding technical papers, auto companies trying to identify the team behind the innovation, and energy analysts predicting a trillion-dollar disruption. And then, Elon Musk spoke again. This time, it wasn't just a short comment. It was a message hinting at collaboration, validation, and serious interest. The tweet appeared just before midnight California time, and within minutes every major tech outlet had screenshotted it. Musk wrote, "Wireless energy is not magic, it's physics. But if these guys have solved efficiency and heat losses at distance, we need to talk." Those 12 words did what no marketing agency could ever achieve. They validated the possibility that this wasn't a hoax, wasn't staged, and wasn't just another internet gimmick. It triggered a wave of curiosity from engineers, investors, and even government energy committees. The following week, speculation turned into movement. Representatives from multiple companies landed quietly in Johannesburg, not through press announcements, but through trackable aviation records and hotel check-ins. Among them were observers from Tesla Energy, SpaceX Propulsion Consulting Partners, and a European EV infrastructure giant known for rapid deployment charging stations. Meanwhile, in the South African facility, preparations were underway for a more controlled demonstration, this time focusing not on the vehicle itself, but on the power link. Because the secret turned out not to be the truck, but the transmitter array behind it. Inside the lab, coils wound with superconducting alloys sat in precision frames. Modulation systems tracked the vehicle's position in real time, adjusting the transmission beam to minimize power loss. It wasn't exactly free energy. It was targeted power, like Wi-Fi for electricity. During a briefing, the lead engineer, a calm man in his late 40s with thick glasses and a slow smile, explained it simply. We don't transmit power everywhere. We transmit it only to the receiver we've paired. That's why we don't cook birds or heat up the air. It sounded like science fiction, yet the data logs scrolling behind him showed stable current transfer over distance with less than 11% loss, a number that would make conventional wireless researchers raise their eyebrows. But the real pressure came from outside. On Twitter, debates raged between physicists, skeptics, and techno-optimists. Forums filled with threads claiming it violated Maxwell's equations, while others pointed out the irony that the system's creator shared the same name as the physicist behind those very equations. Elon Musk, meanwhile, didn't argue. Instead, he sent a private invitation to the engineering team. Come to Texas. Bring your transmitter coil. We'll run independent tests at Starbase. That message changed everything. For the South African team, it wasn't just a validation, it was a test under the strictest engineering environment on the planet. Starbase was known for blowing up rockets, tearing apart engines, and pushing prototypes until they failed. If the wireless EV system survived there, no one could call it a trick. The team accepted. Fast forward 3 weeks, and a small charter flight touched down in Brownsville, Texas. On board were the lead engineer, 2 technicians, and a shockproof container housing the transmitter coil, signal alignment units, and diagnostic interfaces. Starbase security escorted them past the shipyard where towering stainless steel Starship boosters rested against the coastal wind. In the testing bay, engineers from Tesla and SpaceX waited, laptops open, sensors ready, cameras pointed. No journalists, no hype, no live stream this time. Just data. For the test vehicle, they didn't use the African truck. They used a stripped-down Tesla platform, wheels, chassis, and a bare battery pack. No body panels, no accessories, nothing that could hide a secret transmitter. The South African team set up their unit 15 meters away. The SpaceX engineers monitored ground interference. The Tesla technicians calibrated the battery readouts. Then the lead engineer nodded once. Send the pulse. A brief vibration hummed through the testing cage, and then the Tesla platform rolled forward. No wire, no pad, no contact. The SpaceX data, lead stared at his thermal camera feed. Transfer's clean, he whispered. The Tesla engineer typed rapidly, then froze. Voltage stable. No spike. Musk wasn't in the room during the first pass, but he walked in during the second, flanked by technical advisors. He didn't speak at first. He just watched the stripped-down chassis move, powered by nothing but air and physics. Then he finally broke the silence. How far can you push this before the losses break? The lead engineer didn't hesitate. That depends, he replied. How far do you want to go? Elon smiled for the first time. The negotiations didn't happen in a boardroom. They happened during a walking tour of Starbase, between steel monoliths and cranes lifting rocket hardware into place. Elon walked ahead, hands behind his back, while the South African team followed with cautious confidence. He asked questions without slowing down. What frequency band are you using? How are you handling interference with moving receivers? Can the beam be multiplexed for multiple vehicles at once? Have you tested at scale, or just prototype level? Every answer was met with a slight nod, not approval, not disapproval, just mental categorization. The team could tell he was already thinking 10 steps ahead. By the time they reached the vertical assembly bay, a SpaceX propulsion specialist joined the group. He asked one question that none of the journalists or Twitter skeptics thought to ask. What happens if you apply this to aerospace? The lead engineer paused, as if choosing his words carefully. In theory, he said, if you could supply enough power over distance with beam steering, You could reduce fuel requirements for certain flight phases. High-altitude vehicles. Drones. Maybe more. The propulsion specialist raised an eyebrow. Beamed power flight? People have been dreaming about that since the 70s. The engineer just smiled. People dream until someone builds it. Meanwhile, in a separate room nearby, Tesla energy analysts were studying the coil's diagnostic logs, trying to understand the true efficiency curve. One of them turned to his colleague and whispered, "If this hits 20 meters with single-digit loss, charging stations become optional. And if you make charging optional, infrastructure becomes software, not hardware." That sentence summed up the panic rippling through the global EV industry. Because while media outlets focused on the wireless Cybertruck visuals, energy analysts were focused on what it meant for ownership models, for grid planning, for the entire business of EV charging. Back on the tour, Elon finally stopped walking and faced the engineers directly. "You realize this disrupts more than just cars," he said. "Utilities, transportation, satellites, even military logistics. Wireless power at this range is significant." He didn't say revolutionary. He didn't need to. The team knew exactly how significant it was. "So," Elon continued, "what do you want? Are you looking to license? Sell? Partner? Go public? Or are you just here to prove everyone wrong?" It was a fair question, one that Silicon Valley asked 1,000 innovators before. But the answer was different this time. The lead engineer crossed his arms and replied quietly, "We're not here to sell it. We're here to keep it African." That caught Elon off guard. Not in an offensive way, more in a way that forced him to reevaluate the negotiation framework. He adjusted his stance, thoughtful. "All right," he said. "So, what does keep it African mean in technical terms?" "It means manufacturing on the continent," the engineer said. "It means not stripping IP and relocating production overseas. And it means Africans owning the infrastructure of the future, not just consuming it." There was a long silence. In tech, silence usually means one of two things: rejection or respect. With Elon, it meant calculation. Finally, he said, "Then maybe the play is an acquisition. Maybe it's deployment." The team exchanged glances. Deployment. Not takeover. Not replacement. Collaboration at scale. That was the moment when the tone shifted from negotiation to planning. But what nobody knew, not even Elon at that moment, was that the African team was already in talks with 2 governments, 3 universities, and 1 major energy player. Within 48 hours, emails, encrypted messages, and private calls converged like a storm. Government officials wanted regulatory approval and pilot programs. Universities requested access to the transmitter technology for research. Energy companies were exploring ways to integrate the wireless system into national grids. And Elon Musk's team was scheduling private demonstrations at multiple Tesla facilities. The South African engineers watched it all unfold from their temporary lab in Texas, fully aware of the gravity. This wasn't just an engineering feat anymore. It was a geopolitical, educational, and industrial flashpoint. Every move they made would be scrutinized, copied, or challenged. To maintain control, the team decided on a phased strategy. Phase 1. Prove the technology's scalability without compromising safety. Phase 2. Secure local manufacturing partnerships to ensure production remained on the continent. Phase 3. Establish a knowledge network, giving universities and vocational schools access to technical data, fostering a generation of engineers who could maintain and expand the system. Meanwhile, Elon's team requested a one-on-one session. In a quiet Starbase lab, away from cameras, Musk leaned over a data terminal. "Your energy transfer efficiency is impressive," he said. "But what about environmental factors? Rain, dust, signal interference?" The lead engineer nodded. "We've tested in harsh African climates. Dust, heat, humidity, all accounted for. The beam adapts dynamically to maintain stable voltage, and multiple vehicles can operate in parallel with minimal loss." Elon paused, studying the diagnostic charts. If this scales to fleets, cities could go wirelessly powered, no charging stations needed. That's massive. Then he smiled, a rare, genuine smile, the kind reserved for breakthroughs that shift paradigms. I need to see it in action under stress conditions. Let's run a fleet demo. Plans were quickly drawn. A convoy of 5 vehicles would navigate a mixed-terrain course inside a Tesla testing ground, with transmitters repositioned at different points to simulate urban and rural deployments. Engineers from both sides would monitor power flow, thermal loads, and efficiency in real time. Back at the South African team's base, preparations were underway. Each vehicle was meticulously calibrated. Backup systems were checked twice. Every antenna, coil, and alignment sensor underwent rigorous inspection. This was more than a test, it was a statement. Journalists were not invited. This was not a press stunt. This was pure engineering, unfiltered, faceless documentation of technology challenging the status quo. And as the first vehicle rolled onto the course, powered entirely without wires, the silence in the lab was broken only by the soft hum of energy flowing invisibly through the air. It was more than a demonstration. It was the beginning of a wireless revolution, and the world had no idea what was about to come next. As the first Cybertruck glided across the testing course, the engineers monitored dozens of live telemetry feeds. Voltage remained stable. Energy loss was minimal. Thermal readings were within safe limits. But the real test wasn't numbers on a screen, it was adaptability. At random intervals, the transmitter units were repositioned, simulating moving power sources like drones or urban grids. The vehicle adjusted seamlessly, rolling forward without slowing, its systems automatically syncing with the new energy source. Every adjustment, every correction happened in milliseconds, faster than human reflex. Elon Musk stood at the edge of the testing field, arms crossed, eyes narrowing in focus. He had seen EVs, rockets, and energy grids fail spectacularly. But this was something different. The hum of invisible energy under the tires seemed almost unnatural, like watching physics bend without breaking. Then came the second challenge: multiple vehicles. 5 trucks, each fully operational, started simultaneously from different points on the course. The transmitters had to allocate energy dynamically, prioritizing voltage, compensating for distance, and preventing interference. For a moment, it looked like chaos. Signals crisscrossed, drones whirred overhead, and engineers adjusted their monitors frantically. Then, almost like a choreographed dance, the vehicles moved in perfect synchronization. No collisions. No interruptions. No drops in power. The South African team exhaled quietly. Musk, usually reserved in expression, smiled knowingly. "This isn't just a prototype," he said. "It's a platform." Word of the demonstration couldn't escape entirely. While journalists were kept out, snippets of video and anonymized data leaks surfaced online. Within hours, tech forums exploded with speculation. How far could wireless energy truly go? Could entire cities be powered this way? Could space launches be fueled remotely? The implications weren't limited to vehicles. Drones, satellites, electric boats, and even industrial machinery could potentially tap into the same system. Grid dependency could vanish. Energy equity could be redefined. And Africa, the continent where this technology was born, could claim the future as its own. As night fell over the testing grounds, the trucks continued rolling in carefully monitored cycles. Backup transmitters were deployed, redundant systems activated, and engineers took notes for improvements. The hum of energy became a soundtrack of possibility, silent to outsiders, but monumental to those who understood its significance. In a private discussion later, Elon leaned closer to the lead engineer. "I want to take this global," he said. "But you have to decide how far you want to push it. How fast do you want the world to catch up?" The engineer's eyes gleamed with quiet determination. "We're not here to chase the world," he replied. "We're here to lead it." And in that moment, it became clear. The wireless Cybertruck wasn't just a vehicle. It was a signal of Africa's technological rise, a statement that innovation could originate anywhere, and when it did, the world would have no choice but to pay attention. In the final demonstration, the African-built Cybertruck glided effortlessly across the testing ground, drawing power invisibly from the transmitters scattered around it. Cameras captured the smooth motion, Sensors recorded flawless energy transfer, and engineers documented every detail. Elon Musk watched silently for a moment, then nodded in recognition. "This isn't just a prototype," he said. "It's the future." The team had achieved something unprecedented, a fully operational wireless electric vehicle that could challenge conventional energy and automotive infrastructure. What had begun as a daring experiment in South Africa had now become a global talking point. The implications were massive. Cities could rethink charging networks, industries could adopt self-powered machinery, and Africa had proven it could lead innovation on the world stage. But more than technology, the project symbolized something greater: ingenuity, resilience, and the power of believing in what others might call impossible. As the sun set over the testing ground, the Cybertruck rolled past quietly, a humming testament to vision and perseverance. The world was watching, and Africa had just made sure it could no longer be ignored. The revolution had begun.